Okay, good morning. Welcome to
FamilyMath77.
FamilyMath number 77. So last week we watched this really awesome video called Donald Duck in Math Magic Land.
Yeah.
Was that fun?
Yeah.
What was your favorite part about it?
The math spirit.
The math spirit?
Yeah.
What
The
was
square roots.
You liked the square roots? Yeah, that was pretty funny, wasn't it? Well, one of the things they talked about in this video were these golden rectangles. You remember them talking about the golden rectangles?
Yeah. Yeah.
And they didn't totally explain what it was. Can you just back up a touch? And so I thought we'd talk about it, because one of the things you said, remember the spiral?
Yeah.
What did you say that reminded you of?
Fibonacci. So
I want to explain how you can just have a rectangle and how the Fibonacci numbers come out of it. All right?
Yeah.
Because it's pretty fun. So a golden rectangle is one where this side ratio to this side ratio, so x plus 1 over x, equals the ratio here. Remember they folded up this side like that and made a new rectangle here? Equals, so the long side to the short side equals the long side to the short side here. X over 1. So x plus 1 over x, that ratio, equals x over 1, that ratio. Okay?
Mm-hmm.
All right?
Yeah.
So there's a couple different ways we could write this. Now you and I are just starting to study quadratic equations, right? So if we multiply both sides by x, we get x plus 1 equals x squared, and then we can find out how long x is.
Yeah.
Does that make sense?
Mm-hmm.
And now you and I might talk about that. Back up just a little. But there's another way to look at it here, which is x. If I divide this out, I get 1 plus 1 over x equals x. And that's the way we're going to talk about it today. Okay? Now, I know this is a little complicated, but do you understand what this says at least? A little bit?
1 plus 1 over x equals x?
Yeah, does that make sense?
Sort of.
Sort of? Okay, good. All right, so the way we made the Fibonacci spiral, or the way we made a spiral in here, is we kept doing folding up here. So we folded up like this. We had a rectangle here, folded up here.
And then I kept.
Yeah, so I think I've got this right. I hope I do anyway. And like that.
Mm-hmm.
Okay? So I may not have drawn it perfectly. In fact, there's no question I didn't draw it perfectly. But so we had kind of a neat spiral. And you said this kind of looks like the Fibonacci spiral, right?
Yeah.
So let's see if we can find the Fibonacci numbers hiding in here. Are you ready?
Yeah.
Okay. So let's look at this equation here. 1 plus 1 over x equals x. That seems like a pretty cool equation, right?
Yeah. 1 is a Fibonacci number.
1 is a Fibonacci number. That's good. 1 plus 1 over x equals x. Now, if x is 1 plus 1 over x, maybe I can just change this x into 1 plus 1 over x. Hey, I've got another x there.
It's going to
1
be
plus 1 over x. Hey, I've got another x here. Hey, that's just 1 plus 1 over x. Hey, why won't those x's go away?
It's a continuous fraction for infinity.
It's a continued fraction. And so I get all these 1s. And so maybe we can try to understand what these 1s are. Well, now, so, like you said, if I just have a 1, that's the beginning of this, right?
Yeah.
Okay. Now what if I do just the first part, 1 plus 1 over 1, the next part I mean. That's 1 plus 1, 1 over 1 is 1. So now I get 2. Now what if I continue this? This is 1 plus 1 over 1 plus 1 over 1, or 1 plus 1 half here. 1 plus 1 is 2. So what is 1 plus a half?
It's 3 halves.
3 halves. Actually, why don't I write them out like this? 1, 2, 3 halves. Now what if I continue? 1 plus 1 over 1. Woo. Well, this is 2, right?
Yeah.
So that's 1 plus a half, which is 3 halves. Now I flip it upside down, I get 2/3. I get 1 plus 2/3, which is
5/3.
5/3.
So you can cancel the fractions if you multiply.
If you multiplied, you'd be canceling the fractions. But right now, we're just looking at these as the individual numbers. Let's look at another one. Now, one thing you notice is it always looks the same, right? So we just
It's like
figured
a
out
fractal.
that 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 was 5/3. So this whole thing here is 5/3. Now it's on the bottom of a fraction, so I flip it upside down. I get 3/5. And what's 1 plus 3/5?
It's 8/5.
8/5. That's my next term.
This doesn't look like Fibonacci numbers to me.
It doesn't look like Fibonacci numbers. Okay, well, let's see. Let me do another one. I just learned that this bottom part here was 8/5. Now I put it on the bottom, flip it upside down, and I get 13/8. Okay?
I
It
think
seems like it's getting closer and closer. And
Wait. What do you say?
I think I see a pattern. If you add an extra 1 here, you get 1, 2, 3, 5, 8, 13, which are Fibonacci numbers, and 2, 3, 5, 8 are Fibonacci numbers too.
Oh, how interesting. What if I write my fractions like this,
it also
and I get the Fibonacci numbers on the top and the Fibonacci
it
numbers
also
on the
drifts
bottom?
closer and closer to 1. Well, because 3 halves. Well, it gets just farther and farther away from 1.
Well, we'll see. Well, that's a topic for another time.
Yeah.
But the interesting thing is, when I look at what these fractions are, they're the Fibonacci numbers on the top and the Fibonacci numbers on the bottom. And in fact, if we had a calculator, you would see these numbers would get closer and closer to 1.618 something. Okay.
Yeah.
So interestingly enough, your observation that we had the Fibonacci numbers hiding in that spiral
Yeah.
was actually right. They are hiding in there, and they're hiding in there. So isn't that amazing? Just with a rectangle, where you take it and you flip up the edges, then you flip up the edges, and then you flip up the edges, and then you flip up the edges, and flip them up, and you get this cool little spiral. The Fibonacci numbers are in there.
Cool.
And that's why people thought, that's not exactly why, but people from ancient Greece thought that these golden rectangles were really special. And the Donald Duck movie showed you that they were in a lot of places, right? Remember
Yeah.
they were at the Parthenon?
Yeah.
Remember at another place they were?
Well, at a temple of Athena.
At the Temple of Athena, good. Do you remember another place they were?
They were at like some sort of temple. I
They
don't
were
remember.
they were at another temple, but they were in a lot of
10
places.
temples.
It's pretty cool. All right.
And on the statues were the golden rectangle.
Right, the golden rectangle is part of the statues too. Okay, so that's cool. I'm glad you noticed the Fibonacci numbers were there, and I'm proud of you for noticing the Fibonacci numbers there. Good job, guys. Good job.